Hello everyone and welcome back to the channel. Today's video should be about 5 minutes long, which depending on who you ask is actually a pretty long time, Samantha. So anyways, getting into it, we're going to be talking about binary search today, which is a pretty fun topic and should be pretty easy to cover. I know a friend who once tried to actually binary search for his bench press max from 100 to 400 pounds, and needless to say, he is now dead. So anyways, let's go ahead and get into the PowerPoint as per usual, and we can go ahead and knock this video out and get on to the next one. Okay, so as discussed, today we're going to be doing binary search for our topic of the day. And basically the general premise of binary search is that unlike with our typical, searching for an element in an array, where, we can't assume anything about the order of the array contents, binary search is really useful when you know that you're actually searching through an ordered array. And so like I mentioned in the past, if you're searching through an unordered array, what's actually going to happen is you have a linear time complexity because you have to scan for every single element to find a given element. But the cool thing is when you actually have a sorted array, we can do this in better than linear time. And the way that we do this is ultimately by basically doing the same thing that we might do when looking through a dictionary for a word. Basically, imagine you have an English dictionary and you're looking for like the word cat. You might open up to a random page and you'll see that you pulled up the word hat, and then you'll say, okay, well, C is before H, so I should, get a previous page. Now you pulled up the word boy, cat is after boy, so now you're looking further to the right. And so yeah, that's kind of the general premise, but I'm going to go ahead and outline that more concretely in the next slide. So here's the general intuition is imagine we have the following sorted array, and we're going to search for the element 12. The first thing we're going to choose is basically kind of a random midpoint or pivot point, and typically this is chosen in the middle of the array. So in this case, you can see that the middle element is going to be 15. And we basically say to ourselves, okay, well, 15 is not equal to 12, so we haven't found our element yet, but we know that 15 is greater than 12, and because we know that the array is sorted, we know that we can now only look towards the elements that are left of 15 in order to potentially find 12 if it's in there. So in that case, we're going to cross out elements 15, 24, 39, and 41, and then we're going to start binary searching the left half of our array. From there, we then take again the midpoint of our remaining array elements. In that case, it's going to be 7. We know that 7 is actually going to be less than 12. They're not equal, it's not greater than 12, so we know that 12 is going to have to be both to the left of 15, but also to the right of 7. So now we're going to cross off elements 3 and 7 because there's no reason for us to search for them anymore. Then finally, the last piece of the puzzle is checking the remaining element of the array. In this case, it happens to be 12. If it wasn't, we would have some sort of base case condition that would actually allow us to stop searching and accept the fact that that element is not in the array. So as you can see, we've found 12. So let's actually go through the pseudocode for a binary search in order to figure out how this works, and then ultimately the last thing we'll do is analyze the runtime complexity. So the actual algorithm for the binary search is pretty simple. In this case, I've done it recursively. However, you could do it with a while loop as well, and the base case would be pretty similar for kind of the loop condition of the while loop. So basically we have these two things called a left and right pointer, and the left and right pointer is basically going to tell us which parts of the array that we're still considering for searching for the element that we want to find. Nums is just the actual list of numbers, and then toFind is the element that we're looking for to see if it exists. So the first thing that happens is if our left pointer that we're looking at is greater than our right pointer, we can consider that the base case and know that the number is not in the array. Otherwise, we want to basically find the mid index of the array, which is L plus R over 2, because that's basically the middle point of the elements that we're considering, and then we actually go ahead and get the value at that index, which we can call midpoint. If our midpoint is actually equal to the element that we're looking for, then great, we found it, and we can go ahead and return the index of that. Otherwise, if it's the case that basically the midpoint is greater than the element that we're looking for, we know that we have to search only in the elements that are left of the midpoint. And then we can recursively call binary search using the new parameters. As you can see, in this case, we would be adjusting the right parameter of binary search to be the middle index minus 1. Similarly, in the case that basically the midpoint is going to be less than toFind, we know that our element, if it exists in the array, is going to be to the right of that midpoint. And as a result, we can set the left parameter of binary search to be mid-index plus 1, keep right as is, and then go ahead and recursively search again. So if you're starting to think about this, we can see that every single time we do a search, we effectively slice the number of elements that we're considering to look at in half. And so as a result, what that basically means is that we have a logarithmic time complexity. as we mentioned, this is going to be significantly faster than linear time complexity for searching for elements in an unsorted array. And for this reason, binary search becomes so useful. It comes up in a ton of problems where, it's basically an extra optimization when searching through an array that's already been sorted. And as a result of that, it's very important that you know how to binary search, because there are tons of problems that kind of, slightly adapt it in many different ways. And knowing how this works very well is going to be huge for, both passing interviews and also anything to do with competitive programming. Alright fellas, well that's all for today. I hope this video was more enjoyable. It seems like people enjoy taking in algorithms content in more digestible, smaller chunks, which makes sense. I also like eating small chunks, so, it's kind of how it goes, and I'll be seeing you all in the next one. We have a fun collaboration coming up soon, and I'm looking forward to sharing that with all of you.